Today's going to be lesson 70, 11-4, similar space figures. Similar space figures are basically, they have the same shape but not necessarily the same size. What we need to do is determine if things are similar. In doing so, we need to determine if the side lengths or the corresponding sides are in proportion. So therefore they would have the same ratio. As in this example here, they basically have 5 corresponds with 35, so they have 5 over 35. 10 corresponds with 70, 10 over 70, and 5 corresponding with 35, 5 over 35. All those ratios would reduce to 1/7, so this would be a similar figure. Not only looking at similar figures, we will also be talking about surface area and volume and how scale factors change. This would be an example of a scale factor here, 1/7, how they change regarding surface area and volume. So in your first example here, example 1, what we want to do is I normally like to take and go ahead and label my figures right away. And in the example above, they do say or reference AB. So this first one I usually reference as A or figure A and figure B. Now, remember, similar figures have corresponding sides. So 28 up here in figure A would correspond with 14 in B, giving us 28/14 as a ratio, reducing to 2/1. You need to check all those sides to make sure that they're in proportion. So we'd also need to check 12 and 6, which would give me a ratio of 12/6, also reducing to 2/1. So as you notice here, the proportions are equivalent. Therefore, these two figures are similar. Example 2, again, label them. Figure A, figure B. A, in this side, I'll start out with 50 here. 50 corresponds with 20. That reduces to 5/2, leaving us with 100 here. Now, as you notice, the 100 here is the whole diameter. Over here, we don't have a diameter, we have actually a radius, so we need to have equal measures here, or we need to compare apples to apples. So if we're comparing the diameter here, we need the diameter in figure B. Figure B, your diameter would be 60 centimeters, so we would have 100 over 60. 100 over 60 would reduce to 10 over 6, and 10 over 6 would reduce to 5/3. So as you notice here, these would not be similar figures. They do not have the same proportion. Therefore, they're not similar. The next concept that we'll tie in is tying in the surface area and the volume scale factors. Previously, back here, when we determined similar and not similar, these are the scale factors we found. 2/1, 2/1, 5/2, 5/3. Those are all scale factors. Now we're going to see how scale factors change regarding surface area and volume. Now if you look here, the ratio of corresponding side lengths, okay, AB, we stated our figures as AB. When we are dealing with area, we cannot use AB. The ratio that we need to use is A squared B squared. Area is squared. Volume, on the other hand, is cubed. So instead of using AB or A squared B squared, we need to use A cubed B cubed because it's dealing with volume. So down here in example 3, it says each pair of figures is similar. We already know they're similar, which means that they would have the same scale factor. It says use the information given to find the scale factor of the figure on the left to the figure on the right. So again, I started out, I labeled my figures AB. I notice here that this is a volume measure regarding the cubed factor. So I am dealing with the volume ratio. Volume ratio is a cubed, b cubed. So what I've done is I took the two pieces of information that I know, and that is the volume. So 112 over 896. This would reduce to 1/8. Now 1/8 is not the scale factor. 1 over 8 is a cubed, b cubed. Okay, this fraction here reduced to this. So this is really a cubed is 1 and b cubed is 8. Now, you need to get rid of the cube in order to get the scale factor. So in order to get rid of a cube, you have to use a cube root. A cube root would look like this on your calculator, if you can find it. What you need to do is, on most of your calculators, put in 1 and find the cube root of it. So in for this x, you're going to end up putting a 3 in it to get rid of the cube root. You put an 8 on your calculator, do the cube root. You're going to put a 3 in place of x. It's no longer the square root function. Basically what a cube root is saying is what number times what number times what number would give you that number. So what times what would give me 1. All that would be 1. Down below here, what times what would give me 8? Well, that would be 2. 2 times 2 times 2 would give me 8. So when you take the cube root of 1, you get 1. The cube root of 8 would be 2. So 1/2 is actually our scale factor. Example 4, when we look at example 4, we're now dealing with an area. Labeled my figures. I am now using a surface area or an area ratio. Therefore, I'm squaring it, a squared, b squared. Put my surface area in a fraction in the respectable form a and b. So 12 on top and 147 on the bottom. This ratio would reduce to 4 over 49. Now remember, 4 over 49 is a squared, b squared. We want the scale factor. The scale factor is a over b. To get rid of a square, we've worked at getting rid of a square a lot with Pythagorean theorem and many other things. To get rid of a square, we're going to use the square root function. So basically, we take the square root of our numerator, the square root of our denominator. The square root of our numerator is 2. The square root of the denominator is 7. And that is our scale factor. So the scale factor in example 4 is 2/7. The last two examples that we'll cover here is we'll be given two figures, and again, they are all similar. We need to find the scale factor, the area ratio, and the volume ratio of the two similar figures. So in example 5, the first thing that you would want to find out is your scale factor. Your scale factor is a over b. Again, labeled our figures. Now they're similar, so I don't need to test 12 and 6 and 32 and 16. This is 16 because again, it's a diameter. Okay, so I don't need to test them both. I only need to test one side length and make sure that I'm using the respectable things here. If I'm using 32, I need to use 16. But I chose 12 and 6. That would reduce to 2 over 1. So this is our scale factor ratio, is 2 over 1. Your area ratio, remember, is a squared b squared. Well, you need to use your scale factor, a over b. A over b is 2 over 1. If I put 2 and 1 in the respectable spots for a and b, I need to square them for an area ratio. So I have 2 squared over 1 squared, and I wind up with 4 over 1. So the area ratio of the two similar figures is 4 over 1. The volume ratio. Volume is cubed. Take your scale factor ratio, 2 over 1, substitute in. So I have 2 over 1. They're both cubed. 2 cubed is 8. 1 cubed is 1. want you to go ahead and give example 6 a shot. So go ahead, pause the video right now, label your two figures, and then come back and we'll double check to see how we did. So go ahead and pause it. Alright, now that we're back, scale factor A over B, 4 over 24 reduces to 1 over 6. You may have chosen 6 over 36, still goes to 1/6. Area is squared. I put in 1/6. Square them both. I wind up with 1/36. Volume is cubed. Put in 1/6, cube it, and I wind up with 1 over 216. This concludes lesson 70 on similar figures, scale factors, area and volume ratios.